Hey class, welcome back to the unit on circles, and what we're going to do today is talk about circles in the coordinate plane, which means we're going to deal with equations of circles. And it's really kind of fun because I like algebra and equations are fun. And so we're going to talk about circles in the coordinate plane, we're going to write equations, we're going to use a center and a point, and we'll even graph circles. So much fun awaits. So let's get into notes. Now there are a few notes here that I do want to talk about, so we'll hang tight, and I'll teach you some neat algebra tricks momentarily. So there's a theorem that deals with the equation of a circle, and you deal with the center. So imagine the center has ordered pairs at hk, any random ordered pair, and it has a radius of any random length. Well, if that's the case, then the equation of that circle, the set of all points equidistant from that fixed point, would be this equation. So no matter what ordered pairs exist, they meet that equation standards and they make the graph of a circle. Now here's the trick. It looks kind of a confusing equation, but what I want to teach you is a bit of algebra and the concept of parent functions. So if you have a parent function, you have a general sense of what the picture looks like. In this case, it's a circle. Okay, so your x is squared, your y is squared, and your radius is squared. That's a parent function. But what may happen to the equation if the graph moves? Okay, so if we're shifting the graph. So in the case of shifting a graph, both to the left and up, you will have your standard form equation. So if we move the graph to the, to the right, did I say left? Anyway, if we move the graph to the right and we move it up, you have a different looking equation. That is actually the standard form equation. Notice what's happening here. We have shifted a graph to the right, but then the x has a minus h with it. And we have shifted the graph up, but the y has a minus k with it. That's some interesting stuff that we can talk about in a whole nother thing about graphs in general. But if you pick points and plot them, you'll see that to be true. So that in a very similar manner, what would happen if we took the very same graph, and instead of shifting it to the right and up, we shift it to the left and down? How would that impact the parent form or the parent form? So with the standard form equation, instead of having x minus h, if a shift to the left, it would be plus h, and with a shift down, it would be plus k. Now you might be thinking, Katz, I don't understand anything you just did or said, so can you give me some examples? And the answer is yes. Yes, I can. So take a look at this example. Pretend we have an equation that looks like this. What would be the center of the circle, and what would be the circle's radius? Well, from the equation, for following standard form practice, it says x minus h, but the h, the x-coordinate of the center, is that positive number. So for shifting to the right, it's a positive x, which is interesting. So look what's happening. It's x minus 3. That means for the center of the circle, the x-coordinate is in fact positive 3. And since it's y minus 2, the y-coordinate of the center is positive 2. So the center of this equation is at 3, 2. Positive 3, positive 2. Now what do you think the radius would then be? Well, if it's radius squared as part of the equation, that means the radius squared gives us 4. That means the radius is the square root of 4, or 2 units long. So that's how this works. And you might be thinking, still, Katz, I still don't get it. All right, let's do another example. This one's a little bit more challenging. So here's our next equation. As you can see, we have x minus 7. So in the center of that circle, what would be the x-coordinate? This reads minus 7. So the x-coordinate is going to be plus 7. Funny how that works. But what about the y-coordinate? It says y plus 5. So the y-coordinate is going to be negative 5. And that is the coordinates of our circle. The radius, though, what's the square root of 13? I don't know. This is kind of funny. So if this is our equation, and we have the x squared and y squared equals 13. This is the radius squared. That means what number was the radius that when we square we get 13? Don't rack your brains over it too hard. The radius is indeed the square root of 13. Because remember, square root of 13 times square root of 13 is 13. That's how it works. I know. All right, one more. You should already have the center and the radius by now. If you don't, hit pause and rewind because you haven't heard anything I've said. But you should know this stuff right now. Okay, so the center of this circle, the x-coordinate would be -5. The y-coordinate would be +6. And the radius, of course, is 5, the square root of 25, 5 units. Okay, so that is how equations of circles work. Okay, so there's that. We'll do some more practice momentarily. Now, another thing we're going to need to remember for this lesson is the distance formula, and you'll see why momentarily. Now, if you recall the distance formula, it's going to come back in handy, but these are the notes. Okay, so the notes on circles is everything here. I'm actually done with material, but let's do some practice. We're going to apply these notes now, okay? Okay. First example, so here's a question. What is the standard equation of the circle with a center at 5, -2, and a radius at 7? Well, remember how the equation works. It's going to be x minus the x-coordinate of the center, and then y minus the y-coordinate of the center, and the radius squared. Okay, so we're going to apply that right about now. Look how easy this is. It's going to be x minus 5. Sweet! X minus 5 squared. And then y minus -2. Wait, what? Yes, you heard that correctly. Y minus -2. And y minus -2 looks like y plus 2. Did you catch that? You should have. If not, shame on you. Pause, rewind, listen again. Now, what is that going to be equal to? It's going to be equal to the radius squared. So, not 7, not the square root of 7, 7 squared. Ladies and gentlemen, 49. And there is our standard equation of a circle that meets these criteria. The center at 5, -2, and the radius of 7. And that is how it works. I have no other work to show. It's all like paying attention. So here's the next thing. Again, standard equation of a circle with center at 3, 5, and a radius of 6. You should be done by now. You should already have the answer for this equation. Again, x minus the x-coordinate of 3 squared, and then y minus the y-coordinate, which is 5 squared, equaling the radius squared. And there is our standard equation of a circle meeting that criteria. That is how equations of circles work. So let's do some more examples. Yeah. All right, so here's another one, a neat one. The question is, what's the standard equation of the circle that meets this category? Now, we already know the center. Okay, we already know the center. The center is at 1, -3, and it passes through the point 2, 2. So this is our diagram of the circle. What we don't know, hopefully you figured that out by now, what we don't know is the radius. Now, what is the radius? The radius goes from the center to the edge, right? So it's the radius is what we're missing. Okay, so how would we find the radius of this circle? We only have 2 ordered pairs. Remember when I said we might be using the distance formula? Yep, we're going to be doing that. Okay, so that's how we would find the radius. The radius is found using the distance formula. Now, how does the distance formula work? Well, remember, it's an offshoot of the Pythagorean theorem. So we're going to subtract our x's, 1 minus 2, -1. And then we're going to square that. And we're going to subtract our y's. -3 minus 2 is -5. And then we're going to square that. Okay, so it's an offshoot of the Pythagorean theorem, but just quicker. So we work inside our symbol. -1 to the second power is +1. -5 to the second power is 25. So the radius is then the square root of 26. Now, don't go punching that in your calculator. We're going to hit pause here because I want to bring you back to the example that we did from the equation. Remember the second example, where if the equation read 13, what was the radius? The square root of 13. Because the square root of 13 squared is 13, right? So if you're using the distance formula and you come up that the radius is the square root of 26, fine. That's fine. That's totally the radius. How will that impact the equation? Let's take a look. So we have our radius. How does it impact the equation? So here's our center. Again, x minus 1 squared. And then y, see that minus 3? Y plus 3 squared would be equal to the radius squared. What is the square root of 26 squared? 26. You don't need to hurt yourself. Everything can work itself out quite neatly. Okay, so we have to be able to work with the distance formula to see those things, and then kind of chill out when we come up with funky looking numbers. Because for the equations, we square them anyway. So there's that example. Let's do another one. All right, so standard equation of a circle with center at 4, 3, passing through negative 1, 1. So we already have our center once again. The center is given to us, 4, 3. Yay. What we don't have is the radius. So how do we find the radius? Distance formula. So we subtract our x's. 4 minus negative 1. If you don't know that's 5, use a calculator. And then 3 minus 1. 3 minus 1 is 2. So remember, we're going to square everything. Okay, so we're using the distance formula. And it turns out the radius is going to be the square root of 25 plus 4, which is the square root of 29. So if we know that for our radius, we're done. And we don't need to worry about that number, the square root of 29, because the formula calls for the radius squared anyway. So we have our standard equation. It's x minus 4 squared, and then y minus 3 squared, and that would be equal to just 29. You see how this works? It's nice and convenient. Not the hardest thing we've ever done, folks. Not the hardest thing we've ever done. So one last example, because now what we're going to do is graph a circle, because it's nice and fun. And then we'll be done with circles. Nice and easy. So blah, blah, blah words. Made a call on a cell phone. Tower receives, transits call. Way to monitor a cell phone. Suppose the equation, this, represents the position and range of a cell tower. So what does that mean? If we look at this equation, we should be able to find the center of the circle in this equation. If you don't know it yet, that's horrible. Watch the whole thing again. The center is going to be 7, negative 2. So you should be able to see that from this equation. The center of the circle is 7, negative 2. What then would be the radius of this circle? 64 is r squared, so the radius is 8. With that information, we have enough to graph. Okay, so that's all we need to do. We're going to graph it. So we have our order pair at 7, negative 2, and clearly this is going by 2's, right? 2, 4, 6, 8. So that means 7 is here, and then negative 2 is here. There is our center at 7, negative 2. We've got to be careful with how these graphs are working. And we also know that the radius is 8. So from the center, we're going to move 8 units. Okay, so we have 1 unit, 2 units, remember it's by 2's, 3 units, 4 units, 5 units, 6 units, 7 units, 8 units would be our next point. Now, if we're using a compass, we're done. We can totally graph the circle. How? Line up the center of the compass on the center of the circle and adjust the compass point so you can see the point there. So we can graph our circle this way, totally legitimate. Or we can do it by hand. Notice I didn't finish the graph. By hand, how do we do that? Well, we have our point out to the right. What about our radius of 8 going up? 2, 4, 6, 8. Okay, what about our point out to the left? 1, 2, 3, 4, 5, 6, 7, 8 out here. And then we can hand extend it, and then 8 down. 2, 4, 6, 8 down. And then we can kind of sketch our graph. We can finish the circle by hand. It doesn't really matter because we're just sketching the graph. If we're going to use precision tools, we again use the compass. So you can hand draw it or use your compass. So there's your circle. And you can see how close we kind of came by hand drawing it, except the thing moved the second way around. But that's how we graph the circle. You find out where your center is. You find out your radius. Piece of cake. So hopefully you found circles not the most challenging thing we've done, maybe even in the best bet a little bit fun. Take care, and then we'll come back for the last lesson of the unit. See ya.